Hi, thank you all for coming. I think we can start. Okay, so let me introduce myself and my colleague. My name is Wojciech Lesicki, and I am responsible for Mesos and cloud infrastructure and several security projects. With me is Tomasz Janko, and his main focus is also cloud and Mesos. We both work for Allegro in Poland, so we took a quite long trip to be here with you and share our knowledge about Mesos. We want to focus on our frontline experience, and we hope that could be useful for you. So this is our quick agenda. We are going to tell you what Allegro is and what we do, and after that we're going to tell you more about our Mesos ecosystem, the problem we had encountered so far, how we solved some of them, and how we are going to handle those that still need to be solved. So, what is Allegro? We started as an auction site 16 years ago, and now we are the biggest e-commerce company in Poland and one of the biggest e-commerce business in Central and Eastern Europe. We have 50% of e-commerce market and 80% of m-commerce market in Poland. Every minute, over 600 items are sold on Allegro. So Poland has a population of 38 million of people, of whom 14 million are Allegro users. And every month we have over 200 million visits and 3 billion of page views. In order to be able to handle such a number of users, we have two data centers. We have a OpenStack-based private cloud in which we have 500 hosts and 5,500 of virtual machine. Recently, we have started an OpenStack project, Ironic, which gives us bare metal as a service functionality. We still have part of our environment as PHP monolith, and we are still in the process of rewriting this into microservices. We have around 500 people in IT, most of them are software engineers. And that brings us to the questions. Why we need Mesos? Because of that. Looks familiar? A long time ago, we realized that there is no standard way, no procedures in place to deploy application in our cloud infrastructures, which means every dev team did it their own way. Needless to say, that was some kind of chaotic, a bit of trailblazing experience, and as such, extremely inefficient. And now, Tomasz, the floor is, or stage is yours.
Thank you, Wojciech, for introduction. My name is Tomasz, and I am responsible for developing the cloud solution inside Allegro and taking care of our Mesos deployment. I'm putting for the reference this picture, picturing the basic components of Mesos. Of course, all of them take part in our deployment. We have the scheduler, the Mesos master, Mesos masters, Mesos slaves, formerly now Mesos agents, and Zookeeper for quorum. And that's for introduction. When it comes to our implementation, we decide to deploy Mesos at the OpenStack inside our private cloud inside Allegro. When it comes to co-locating, we decide to split the slaves functionality based on containerization they provide. Because right now we have the Mesos containerizers slaves and Docker containerizer slaves, because when we were introducing this feature, there were serious concerns regarding the Docker functionality, Docker security. The Mesos masters are co-located with Zookeeper and Marathon as the framework for having long-running application. And other very important part of this deployment is discovery. We are using the console for the service discovery inside the company. When it comes to taking the look at the data center and a little bit far away view of our infrastructure, we deploy the Mesos cluster across 2 DC, which are inside the Allegro infrastructure. And right now we are having 3 production phase, the customer phase clusters of Mesos, which one of them is the production. Those 3 clusters are separated by the virtual network, and they are completely separated, and any of them has the complete environment, and they don't cope with each other. For implementing those clusters and keeping the states of them, we are using Terraform. The Terraform is the basic tool that we use for extending the cluster to having the knowledge of how big they are. At this slide, you can see the Terraform command and the result. In this example, I'm simply adding the 1 slave inside the DC2, inside our second DC, which is the basic operation we are doing, which is extending this cluster when the resources are running low. All right, so starting from this, I would like to tell a little bit about our ecosystem and what we do to make the Mesos shine even brighter. At the center of this is, of course, Mesos as the source of our application, our data, etc. And we develop this, the services that are providing the basic functionality and allowing the application to be fully automatic and to be easy to deploy. The other part of it, inside this cloud I'm showing you here, is the developer-based, developer-faced solution that we use for deployments and for having some continuous integration, continuous deployment. Actually, Wojtek will show it in the following demo. All right, so to the services. Sorry. One of the services is discovery, as I told earlier, and this is very important part of our infrastructure and our deployment. We're using it for its basic feature is registering the application and providing the information when they exist in the cluster, but also we're using it for integrating our applications with the external tool, for example, monitoring, for example, the load balancing, and all of this is handled by the discovery tags that are deployed with the application. So to have this automatic services registration, we had to develop our own tool, which is the bridge between the Marathon, which is our framework, and the console, which is installed on every slave, every agent inside our Mesos cluster. And for doing that, this component we developed this component called Marathon Console, and it's working like subscribing to Marathon event bus and just getting the events and registering the application on appropriate console agent on the appropriate slave. And these slides actually show it. We have this two-level Marathon Mesos scheduling when framework is scheduling and Mesos is scheduling and deploying the application on the slave, and our Marathon console is just pushing the information to the console agents, and that information is available as a local cache on the slaves. Also, the other side of this is that when all of that events related to discovery occur inside our infrastructure, we are using the other tool to just push that information inside our main PubSub system inside our infrastructure. And this is the point when external application can just subscribe and pull the events from the Kafka and do whatever they want on it. And this is the only point we're providing the information what is happening inside our cluster. So after having this setup, by having your application running, and your application would like to just ask when the application is interested in run. So it can do by basic console functionality, which is providing the DNS API or REST API just to get the information. You can do it by querying the local agent or console master. And this is, on this slide, you can see the example of that. At the top there, you can see the definition in the JSON format of our application, and just registering that application and just calling the post request to register that application on the particular slave. And by that, I assume the application is actually running here. So you can also define your own health check, and console will make the health checking that application for you. And if it's healthy, you can just query it and get information where it's running and what the basic tags are and information about that application. And it actually can be, you doesn't have to query the local cache, you can query any console agent inside your infrastructure to get that information. All right, so while having the other service that we developed to provide to our application, to our customers inside our cluster is the security. We are doing that by providing them SSL service so they can establish the secure connection between services, between application running on the Mesos cluster, or some services that we provide to this cluster, for example, and how it's working. We have to develop this Mesos hook, which is installed on every agent. And what it's doing that is asking for certificate from our certificate authority, which in this implementation we are using the console, the vault from the HashiCorp, and using the console as a storage. And by fetching that information from vault, the certification hook is just extending environment of the application that you are running on Mesos, and passing that certificates and private keys inside the environment variables. So then your application can just establish secure connection to other application and to other service. One of those services is config service, when they provide the storage for your application configuration that you can just fetch. And most of that configuration is just some static data provided in text, but also the service provides the possibility for you to store the encrypted data that is more valuable, and you would like to have it stored as secure way. And how it's done is that whenever application is starting, you have this setup of your certificates, of your keys, and you can just establish the mutual SSL connection with that config service. And by doing that, you are authorized, and configuration service can just give you the data that you would like to fetch. All of this is Git-based, and that information is stored in the Git repository, so you can have the peer review of your changes inside your configuration files, etc. And by doing that, you can just make changes by following the standard Git flow. All right, so we have all that setup set, and right now, whenever application is running, you'd like to have some sort of monitoring of that application, and we're providing that by developing our own monitoring solution, which is very strictly based on the discovery. And whenever your instance is just deployed or started inside the Mesos cluster, the events is populated from the console. It's eventually happen to be stored on Kafka, and our monitoring tool can, if you configure the appropriate discovery tag, our monitoring as a service can do monitoring for you. and how it's done. At the center of this solution lies the Graphite. We just use our custom diamond collector to collect the metrics from our application running inside the Mesos cluster, and they are stored anyway. And whenever your application is registered and you provide this basic console tag, your application is just registered, and your configuration, which is based on repo configuration regarding your triggers and your pages configuration, can be used by this mass configuration, and while relying heavily on the code, it can just page you or the operator or whatever person that's interested in help of this application. The other tool, which is working in the similar fashion as previous one, is load balancing as a service. We are at the center of that, and it's heavily reliable on discovery. Whenever events occurs, you have an appropriate tag relating to load balancing is set. You have the monitoring for all of your instances inside of your cluster. So they are automatically, whenever they are scaling up or scaling down, your instances are dynamically configured as the pool inside our load balancing solution. And as I said, at the center of it lies the console, lies the discovery. So your instance is registered, the event is published to Kafka, and this solution called Disco just gets that event, and by doing that, it's just making the risk call to our load balancing and Varnish as a service services, and in result, you have the config configured for you appropriately, and your application have the load balancing. All right, so having that all said, here you have the all in one slide. At the center of this, of course, there are Mesos master and Mesos agents. Well, both of them are the source of the events inside our infrastructure. So they are publishing to Graphite whatever information is provided by our basic collectors. And when applications are deployed, they're making the request to Vault for the certificates. Their certificates are inside the environment, and that information is populated to the console by Marathon console, and further information lies inside the console master. By doing conwatch, we just propagate that to Kafka, and other solutions like mass or monitoring can make their logic on it, and any possible future service that we would like to provide. Thank you.
Okay, I hope now you have an idea how our ecosystem looks like, and we are going to show you how we can deploy a simple Hello World application from our user perspective. So let me just run. Okay, so we start in App Engine console, that is central place for our user to manage an application, and also they can create a new application there. You can choose basic information like name or description, but we can also choose a project template that is predefined information for our application. In this example, we choose Node.js. You can also choose an Active Directory group who have access to our application. And last step will be optional purge of duty checkbox. And now just want to click create. And several processes are going in the background. One of them is copying or cloning sample code to new start repository, or we have also Bamboo package creation and Bamboo plan creation. And normally this process takes up to 3 or 4 minutes. We're going a bit faster because we don't want to waste so much time. As you can see, one of the last steps is deploying application into Marathon. We can check some basic information. And we can verify the output of our application. So this is hello world. As you can see, application is deployed only on dev environment. And we can go directly to Marathon to check configuration of our application. As you can see, application has allocated 0.1 CPU. We can check if our application is registered in service discovery, in console, and it is. Now we can deploy a new instance of our application into test environment. We use for that Bamboo. And just after a while, we have a new instance on test. We can check our monitoring, our metrics, here in App Engine console, or we can go into Grafana. And we can also check our basic monitoring in Monitoring as a Service page. We have some out-of-the-box checkbox here, or like, for example, response endpoint time, and everything is green right now. Okay, so in a similar way, our developers have deployed 180 different services with a total of 550 applications in our production environment. To sum up, what our Mesos ecosystem gives us. Fast and easy deployment, especially for new application, which means you don't have to wait for virtual machines to be spawned or Puppet to run. It also gives standardization, so all teams are given the same out-of-the-box tools, which they can easily use whatever app they are working on. Moreover, automation, and we all know automation is key if you need to scale. And finally, self-healing. So when some instances are lost due to a crash of slave or virtual machines, these instances are recovered without user even noticing. Needless to say, that all means we can save a lot of time. We can spend coding.
All right, so in the couple of next slides, I'd like to share with you our experience while introducing the Mesos to the production system. And they are maybe the most spectacular problem, but those cost us a lot of trouble and time. And I hope those slides will provoke more of this discussion, actually. And starting with our net isolation. You can configure the Mesos to and compile Mesos with running net isolation. And in our standard deployment, when we first were evaluating the Mesos, we decided to have it. It benefits from the metrics, the isolation it provides. But in practice, it turned out to be problem, especially in the test environment when we had a lot of cyclic deployment or some sort of testing. And it turns out when there were a lot of network namespace setups inside the Linux kernel just were panicking, and it was the problem. So we just have to contact our colleagues inside of Twitter and consult this problem, and we just get the solution for that, which is disabling this feature and staying that way. and it's no problem for now. The other problem was that we had, which was pretty drag, was that whenever there were some sort of problem while writing or getting the framework ID from Zookeeper, the marathon just were registering itself again, and the consequence of that was that our resources in the cluster were exhausted, and the new applications could be deployed. This problem was resolved after deploying the 0.14 version, and it was just changing the behavior of the marathon. While doing that, marathon just waits and do nothing if it has this problem with reading the framework ID. All right, deploy constraint. We have this this concept of deploying all of our application cross DC and cross regions. And for doing that, we are just using the constraints which are automatically deploying application across different regions. But it was very buggy, and we had a lot of bug feedback for our developers that whenever they deploy application, the applications isn't high available. For example, it deploys in only one data center, and whenever for example, we are using in our basic deployment the two constraints at the same time, and they wasn't working. Whenever we deployed the application, the instances that were already running that eventually go down were taking into account with the application that will run after the version update. And it was the problem, but we solved in the last release of our framework. Readiness checks. It's the problem that we had with our application whenever we want to deploy the more complex application, which require to have a lot of automation in the background. For example, set the load balancer or set some sort of caches, etc., to prepare it to be allowed to handle the load that we are going to just stretch on in. So we have to develop this solution to check whenever application is really ready, because the checks that are provided by the framework, which are the basic HTTP request, and if it's green, to provide some to be enabling the application to handle the load. We had to develop our own custom wrapper that is checking the application whenever step, and to make sure that it's actually ready for handling the production load. And from this slide, I want to share the problems that we still have that occurs in our infrastructure. And first on the list is the DC failure, which what happens if one of our, as I said, we have two data centers and we're spawning the Mesos across them. What happens if one of our DC just went down? We didn't deploy the solution yet, but we are thinking about having the spare master in HWS and trying to establish quorum whenever DC fail, but we didn't test it yet. The other problem is our application usage versus allocation across the cluster. It's the problem because especially at the early stage of running our application, the developers aren't capable. It's very hard to actually predict your application resources usage, which can change very on the holidays or on the weekends. And it turns out the allocation is a lot bigger than actual usage, and it's the problem. We are developing our own auto-scaling solution, but it's not ready, and it's in early stage of development and adapting, and it's working the instance base. So maybe not the best solution. We're working to solve that. The other problem is the framework that we are using doesn't allow to have the quota for particular user. We are thinking about, for example, installing a lot of framework for each team, but from our perspective, it is a little bit overkill. So we are waiting for that feature. The other problem is that we have no possibility of having graceful shutdown of our application. The basic Mesos functionality with this is to just seek term the application followed by seek kill, and we have the application that require to have more complex logic when going down. So we're waiting for that feature also to have something like that, to have some sort of graceful shutdown. And the other problem is the whole security problem of Mesos. For example, there are a lot of open endpoint inside Mesos or Marathon. For example, there is this open endpoint that allows you to maintenance your cluster, and it's open. We are trying to solve that by establishing some sort of proxy between that, but it's also the work in progress. Right.
To sum up, you have seen how our Mesos ecosystem looks like, the way it works, and also our journey, and the problems we had along the road. And let me just say that although Mesos make our life so much easier and work much efficient, if you should keep in mind if you're integrating Mesos with existing system, it may take some time and effort, but it's definitely worth it. And that brings us to the end of our presentation. For more information, you can visit our blog at allegro.tech or just contact with us. And this is time for questions. So, do you have any questions? Please go.
Can you talk more about the app engine tool you were using? Is that something you developed in-house?
Yeah, this is our, so there's a suggestion to repeat the question. So the question was about App Engine console and if that was something that we create by our own. And the answer is yes, this is our tool. This is central place for managing application. Perhaps we think about going to the open source with this, but I cannot give you any guarantee or time or something like that.
Did you say you have one Mesos cluster across multiple data centers?
The question was about if our cluster with Mesos is between two data centers. Yes, it is.
Okay, how does that work latency-wise? Because I heard that was a problem with computer latency times.
Well, the question was how it's related to latency and Zookeeper latency times. Actually, we are having a lot of problems with Zookeeper and keeping it in sync, and it is of course the problem. We try to mitigate that problem by, for example, because we have collocated Zookeeper at each master, so it is running locally. And most of the Zookeeper clients runs this way. Whenever you provide you have this string of Zookeeper running inside the Zookeeper ensemble, and whenever the first Zookeeper is your local Zookeeper, it tries to get that information from the cache, but that doesn't solve the problem of synchronization. It's only just that you are using the local cache, and whenever the marathon is, for example, changing the leader and an election is set. In most cases, that synchronization is in sync, but sometimes, as I said, we have a lot of problems with Zookeepers, and I can't give you the clear answer because sometimes there was one time when we actually had to recovered Zookeeper from our snapshot, and it was the first approach in the company actually to do that inside our team, and it was pretty fun, but good question.
Yeah, definitely fun.
The question was we are trying to use Zookeeper in observer mode, but you are referring to Netflix solution for doing that. I just forget the name. It was Exhibitor, right? You are talking about Exhibitor or some?
I'm just talking about functionality of Zookeeper. You can have nodes that are just observers, so they connect to master. They are not taking part in the
Ensemble?
voting, but
Yeah, no, we didn't try that. We are having only the ensemble, and we doesn't use the watchers. Sorry?
Yeah, about how long did it take you to implement it from like, just the idea to the actual fulfilling the implementation?
I wasn't at the beginning of the. So, the question was how long did it take to develop this solution that we present from the basic idea to the production, and I guess Wojtek would.
It takes some time, and we use Mesos from around 1 year, and now we are now sure that we can run production there. But that was a quite long process, as I mentioned before, especially if you want to integrate with existing ecosystem. That definitely takes some time.
So related or follow-up to that question, you said there are 500 IT engineers in the company.
Mm-hmm.
How many are dedicated to OpenStack, and how many are dedicated on Mesos and those?
Okay. So for OpenStack and Mesos, we have a team from around 7 or 8 person, but because this is cool ecosystem, we have a couple other teams that, for example, responsible for service discovery or for Vault or some other tools. So it's hard to say how many, but it's a couple of teams.
so you mentioned that you distribute specifics using Vault. How do you use tokens on agent sources? Are you using a single token for each agent, or is each container token?
The question was how we are taking the tokens from the Vault, right?
Yeah.
We aren't. We just keep the Mesos agent in separate network, and we just have the ACLs on the Vault that let us know that this slave is appropriate to just request the certificate for its clients, and we are allowing all of the slave to have this possibility and to pass that information to the instance.
Okay, so thank you for your time.